Okay, section 6.3, you guys are writing down some tables, or you already wrote them down. And the reason you're writing down some tables is to try to make super clear the difference between, if you want to write this down, the main function you saw in Algebra 1A, maybe not the only one, but the main one that you saw, a linear function. And that had a form or an equation of the form y equals mx plus b. I wrote that down yesterday, just barely reviewing it with you. You saw tables like that last year with Miss Sutherland. Y equals mx plus b, where the x's, as they add one, the y's add a constant. And not just any constant. Do you guys notice what's true? Yeah, it's the exact same thing over and over and over and over, because lines have this constant slope where as you go over, you go up the same amount. So as you add to the x's, you add to the y's. Now exponential functions, they're kind of crazy. And those are those ones that we saw yesterday where we have a times b. And then what's up here in the exponent? Coefficient, base, variable, right? Constant, constant, variable, where the variable is up in the exponent. And that makes all the difference, because all of a sudden the table gets way crazier in that as you add to the x's, the y's multiply. And not just multiply, but multiply by the same number over and over and over. And we saw that yesterday. I just wanted to show you an example as far as how the table is different from what you've seen before. And that was over here in the table we saw. Did we actually write it down? I think it was on this page, right? We wrote one table down underneath the words of as the x's add, the y's multiply. That's like a telltale sign of exponential functions. But that's not the only pattern. There's the pattern in the equation and there's the pattern in the table. But there's also something else that we can do with exponential functions. Now, this is technically, this is number 4 through 14. This technically is part of your homework. So I'm just going to ask you really quickly so that you guys get a little idea of what homework is. Can we peek at this homework real fast? Because actually those are all the notes for tonight's homework. But we are going to take a couple more notes as far as getting us ready for next week. Oh, that's really dark. Can you guys even see that? Struggle. There we go. That's better. In your homework at the very beginning. Now sometimes this is going to be a little weird for some of you, so I want to make sure that you know what's going on. Sometimes I might give you problems up here in the vocab and core concept check. Like for instance, usually you guys start down here, but do you notice that I gave you number 4 this time? Okay, so make sure that you look up in order to find number 4. Which of these does not belong? And just a hint, in this one, it's different than the which of these does not belong I do in class sometimes, in that there's really only one that you're looking for. But that one, you guys kind of know the directions, which one doesn't belong. But let's look down here and where the rest of your homework is, numbers 5 through 14. Can we read the directions and make sure they make sense to you guys? The first section says, determine whether the equation represents an exponential function or not. Where should you look in your notes to help you know how to identify whether it's a yes exponential or a no not exponential? Where in your notes are you going to look? Well, the table, do you think the tables will help? Maybe. I'm not sure the tables are going to help though for, maybe for some people. Andrew, you're not wrong. But I think the tables will be more helpful down here, right? Yeah. So what would help with this one? I'm going to help you guys know how to use your notes, because your notes are really, really helpful if you know how. Oh, we kind of did this, sort of, didn't we? We were trying to pick out which of them are exponential. And here's kind of sad, I never actually circled this problem, I'm sorry. I should have circled it yesterday and I didn't. But what were we using to help us with this example? Yeah, we were using this one. So if some of you guys are wondering, remember yesterday we were doing those examples? When we do examples in class, it's very often that they look a lot like homework. And so when we were doing these ones, and we were trying to figure out who's an exponential, who's not an exponential. Remember, a lot of you guys were confused. You thought this one was when he wasn't. And you didn't realize that that one was because he looked a little different. But we were looking back at this guy and saying, okay, what does an exponential have in its equation? Is it allowed to have a number in front? Yeah. Does it need to have a base? But it also has to have an exponent, and what needs to be true in that exponent? Variable. Now, some of you, to be honest, could probably be like, ooh, I could do the homework real fast if I show it to you for too much longer, because you're like, oh, I can use that. And that's exactly what I want you to do this weekend, or even tonight, and get it done for the weekend, is use your notes to help you. But there's also another section of homework, and what does this section say? Okay, here's a struggle. You're not just saying, yes, it's exponential, or no, it's not exponential. You have to give a special name. So is it this one, or is it that one? Now, where are you going to use your notes, or where are you going to look at your notes to help you for that? What Andrew was just saying, right? Because he said, well, we just did some tables, and we just saw this one's linear, that one's exponential. But staring at the table might not be enough. A few of you might need to actually start making the jumps to help you out. So can you do one all together and maybe put it in your notes because it's a homework problem? You ready? Let's do one all together. Which one looks hardest? 11 or 12 or 13 or 14? What do you guys want me to do? 14? You guys are used to the hard ones being at the end, huh? So then number 14. 13. Oh, 13 has decimals. Yeah, do you guys want 13? Okay, maybe we should do number 13 then. Oh, I can't do all of your homework. That's no fun. All right, so let's go ahead and zoom in on number 13. I think you guys are right in that most people don't like the fraction, decimal, those types. So if we look at number 13 for just a second, how do we know whether or not it's linear or exponential? You guys have your notes, right? Because remember, you're supposed to be looking at your notes. You have one table example of linear and one table example of exponential. You guys see it? You see the jumps? Okay. So my question is, what are the x's jumping by that I can fill in every time?
1.
Okay, and not just times 1, right? Not times 1, but okay. But if you look at the tables in your notes, don't both of them have +1s? So that's the same as the ones in the notes. But what's going on down here?
4.
Multiplying by 4?
Yeah.
Now, do you see that here?
Yeah.
Maybe, if you're thinking about money, right? Because couldn't we say that this is 25 cents, same thing as a quarter? And we used to quarters, right? How many quarters are in a dollar?
4.
So 4 of these quarters makes $1. Oh, cool. That was times 4. But even if this one was hard to see, some of you could have seen it here. How do I get from 1 to 4? +3. That's true. But what's another way? Times 4, which matches up with the pattern before. And then again, and then again. Well, then look at your 2 examples in your notes. Maybe you should even highlight linear versus exponential. Or with the color pencil. What does this pattern go along with, guys? Exponential. Linear wouldn't have times. Linear would have add. True? Okay. So far in homework, well, guys, actually, that gets us to the end of this weekend's homework. But we're not going to stop because actually, don't you guys normally feel that homework gets harder as we go on?
Yeah.
So even though this weekend's homework is really easy, I want to get you guys ready in your notes for the problems that are going to get harder. And maybe some of you might even, with extra time this weekend, I'm not saying you have to, but maybe you start working on the harder homework that will be Monday night's homework. Yeah? So it'll be in RedWeb by the end of today. So let's go ahead in our notes and not just stop with the tables and not just stop with the equations, but let's go a little bit further. However, do you guys see how your notes can really help you on your homework if you have them nearby?
Yeah.
Hopefully. They're a good resource. That's why we do them very carefully. So what if I was to give you, here we go, this. What if I was to give you this? Now my highlighting, I'm sorry, it's kind of dark. I didn't realize how the smart board made it look kind of funny. Maybe I'll move my highlighting markers, put it underneath. So what if we're talking about growth? Here we go. This is an exponential function because you have a variable up there in the exponent, just like he's supposed to be, like we just saw with the equations that we were talking about. So in our notes, we're moving on. Good. Some of you might need to turn the page. What if I give you y equals b to the x? What if I give you y equals b to the x? Now, if you guys notice, there's no a in front. If you guys notice, there's no A in front. So I've kind of given you like the easiest one. In the sense of not getting too crazy all here at the beginning. So I'm going to go ahead and give you a picture of the graph without going too crazy. If we were to make a little baby table like you guys just saw with X's and Y's, and if we were to do something like -1, 0, 1, 2. I want you guys to see what would come out. Now, this table just got really small, so I might actually make him big on the other side or on the other page. Let's go ahead and do this. So if I was to ask you, given, so some of you, maybe you didn't have room there, so you can write it right below. We're going to fill in some of these blanks. So I'm given y equals b to the x, and if I want to, fill in the table. We're trying to figure out what on earth his graph looks like. So that's kind of what the second part of homework does. Let me put in those numbers again, -1, 0, 1, 2. Okay. In order to plug in for a table, we have to take each of the quantities one at a time and try to plug in. But what's different than the lines that you guys saw last year is that, well, instead of plugging in a way that we're multiplying, we're plugging in a way that we're changing the exponent. So whenever you're given any sort of algebraic expression like this guy up here, whose table we're trying to fill in, and they tell us what x equals, -1, 0, 1, or 2, we have to plug in to know what goes in our table or what fills in our table. So, you guys locate the x up here in your equation? That's where your eye always needs to go in algebra whenever you see an equation and you're trying to plug in. Does anybody know the really snazzy vocab term for plugging in? Like you're plugging in, that's like a silly way of remembering it. What's the snazzy term?
Distribute.
Close. Distribute means multiplying, but I heard another one. What's the other one? Substitute. Substitution, right? And you guys are used to that, any of my athletes, because don't you have subs in games? Right?
Yeah.
And if there's a sub going into a game, well, someone better be coming off the field, off the court, or else you're in a whole lot of trouble and the ref's going to get you, right? So if you're subbing, someone's going onto the court, someone's going off. Someone's going onto the field, someone's coming off. So if I know that x equals -1, well, the x is going to go off the field and the -1 is going to go on. So y equals b to the -1. And we're going to simplify that in just 1 second to figure out what to put into our table. But guys, what are we going to do if x equals 0? How is it going to change? 1.
1 equals 1.
Well, some of you are already doing the mental math. That's good. But don't you first have to put the 0 in the exponent?
Yeah.
What happens if x equals 1? What's going to be in my exponent?
B1.
B to the 1. And if x is 2, it's b to the...
Fine.
So remember, substitution just says, hey, where's the x? There he is. All right, cool. I have someone new to plug in, a new substitution to make. Another way of thinking about this is kind of like positions in a team. So if you have a football game today, yeah?
Yeah.
So don't most players on most teams have a certain position that they're kind of made for or they're groomed for, they're practiced for, right? In basketball, like your point guard, well, some random post player isn't going to be like, yeah, I'm a point guard. I mean, sometimes if you're a really well-founded player. But otherwise, you kind of have a position. You can think of the x as being a position. And so the exponent position gets taken over or gets filled in with. The exponent position gets filled in with. The exponent position gets filled in with. That's what substitution is, filling a position. So now, hold on, wait, someone was amazing. And when I asked about what happens when you plug in 0, what did you answer?
1.
Because, remember from section 6.1, anything to the 0 power is
1.
Okay, so we can put that up here in our table and say, okay, we figured out a number. But for the rest of these guys, it's kind of a struggle because do we even know who B is? Is he a variable? Is he holding the place for a number? Yeah, we don't know who he is. It's B. But anything to the first power is itself. Anything to the second power, well, I don't know who he is. So if it was 3, I could do it. If it was 4 squared, I could do it. But I'm kind of stuck. Sometimes it's really hard when you deal with a very general equation because you don't know what it is. All you know is, okay, the b is supposed to be there. I know to the 0 is 1, but everybody else has a b. I don't know. So right now we're just writing what would be there, depending on if b changes. But can anybody help me out with this -1, dude? From our properties of exponents, anything to the 0 power is 1, but what about this guy?
Negative b.
No, careful. Negative exponent. Go in your notes to your flip book. Go in your notes to your flip book. The exponent rule book. Can you find for me negative exponents? Which page is it in your flip book? Negative exponents. Did you find it? Okay. For those of you that didn't find it, help us out, guys. It's on page 3? Is it on page 3? Okay, so negative exponents, if we turn to our flip book, page 3, what does it say? To turn a negative exponent into a positive exponent, what are we going to do?
Flip it.
Flip it. Cross the line, change the exponent sign. Now, hold on. Flipping. How does flipping work if you don't really have a denominator? This one doesn't really have a denominator.
You make a denominator.
Yeah. Anything is over 1. Make a denominator. And then where is that b to the -1 going to go? Cross the line, change the sign, so no longer negative, it's going to be positive. And once he leaves the numerator, who's left behind that was kind of always understood to be there?
1.
Y is here.
Equals.
Equals is there. Yeah. When the b left, the 1 remained. So there's always like a 1 that's understood. So we would have 1 over b. Now I know it's kind of crazy, because there's that b in there. But can I show you what's going to happen on the graph when x equals -1, x equals 0, x equals 1, x equals 2? Without us even knowing who b is, I can kind of tell you what's going to happen based on my pretending that b is a number. What if we pretended that b was 2? If b was 2, then b to the -1 would be 1 over 2, right? 1 over 2 is a very small number. Something like this. And then, well, the next one, b to the 0, 2 to the 0 would be 1. It would be up like this. B to the 1 would be b. I would actually go up here. And that would go up twice as much as that. So here's what every exponential, if it's a 2 or a 3 or a 4 or a 5, every exponential is going to look like, swoop, there it is. It's not going to be a line. It's going to be a swoop. Because exponential functions grow faster and faster and faster and faster and faster. So they get bigger and bigger and bigger. 1 second it's 1, the next second it's b squared, and the next one's going to be b cubed, and b to the 4th, and b to the 5th. It's going to multiply and multiply and multiply. That's why if you ever hear like a professional speaker, like a motivational speaker or a preacher, and they say it's growing, or even like the people on the news that are trying to, doomsday is coming, and they say our debt is rising exponentially. They're basically saying it's getting worse and worse and worse and worse and worse and going faster and faster and faster. Now here's something about domain and range. Did you guys learn domain and range last year?
Yeah.
I think so. Domain has to do with all the x values. And range has to do with all the y values. Good. My silly way of remembering it comes from my Algebra 1 teacher a long, long time ago. Because my Algebra 1 teacher said, whenever you see domain, I want you to think domainix. Sounds kind of like a medicine. My mom used to work in a doctor's office. Domainix kind of sounds like a medicine, and then think of the cute little rangy. With a little y on the end. A little rangy, and then domainix. I don't know, it was silly, but I remembered it. And if you guys remember domain and range, can I show you something real quick about domain and range? I made this actually for the pre-cal kids, because guess what? They have to know domain and range, and they had forgotten it all. Summertime, it's a struggle. So I made them a quick little reminder as to how they can picture domain and range. And maybe we'll do it too someday if we have a little more time. But I made them a domain and range reminder book. To where, if you want to know domain, you have to ask yourself the questions, how far left does it go, and how far right does it go? Because we're asking ourselves, what are the x's, right? Domain, asking ourselves all the x values. Range asks a different question. range answers how high to how low, because we're looking for the y values or the heights. So if we do that for, wait, that's not what the exponential function looks like. Forget him. Nope, that's not what the exponential function looks like. Forget him. What does the exponential function look like?
Y equals
Isn't it a swoop? There it is. Yeah, is that okay? If that's my exponential function, swoop, there it is, y equals b to the x. Here's my question. If I was to take this, guys, how far left, if I was to keep going, how far left does this guy go? If he keeps going and going and going. How far left? Does he stop, or is he going to keep going left? Yeah, he's going to keep going, keep going, keep going. Okay, fine. How far right is this guy going to go? Yeah, he's going to keep going and going and going and going and going, right? So my domain is going to be all real numbers. Forever left to forever right, my domain is all real numbers. Let's fill it in. Domain. Who were the x's? How far left to how far right? All real numbers. That one's not too bad. Those are for our x's, or that's for our domain. But you guys be thinking ahead to the range. Can you be thinking to the range? Some of you guys are already thinking about the swoop, trying to figure out what question we're going to be asking for range. So range, okay, hold on. Let me get my range. We're asking ourselves the question, how high to how low? What do you notice about how high this guy is going to go as we keep following the swoop up? But how high? What's going to happen as he keeps going? Yeah, it's going to go infinity high, because doesn't the arrow mean it's going to keep going and going and going? I was trying to show you that it keeps going. I don't want to write on my mark, but it's going to keep going and going and going. The arrow says, okay, even off the page, it's going to keep rising. So how high does it go? Forever high. But question, how low does it go? Okay, yeah, there are these weird things in graphs called asymptotes. Have you guys ever seen an asymptote? Some people call it an asymptote, because that's how it's spelled. Kind of like, have any of you guys ever thought of Wednesday for Wednesday, like how to spell it, right?
It is Wednesday.
It is Wednesday, not Wednesday. Yeah. That's kind of like how asymptote is. I'm going to show you how to write it in just a second. But this exponential function has an asymptote, a horizontal one. So guess what? It's actually going to get closer and closer and closer and closer and closer, but never pass. So when I ask how low, it actually doesn't go any lower than 0. It doesn't go any lower than 0. It's never going to go to any of these negatives down here. So y greater than 0.
Oh.
For the y values, it's going to be greater than 0. And the reason why that's true is because you have, and we always show it with a dotted line, this thing called, I know it's a really silly name, A-S-Y-M-P-T-O-T-E. It's called an asymptote.
All right.
You see what I see? Asymptote? It's just because I'm trying to remember how to say it, like Wednesday. So asymptote. But it's called an asymptote. And it's a special thing on a graph, or a special characteristic of a graph that says, you shall not pass. Some people have like Lord of the Rings and Gandalf up there being like, you shall not pass, shall not pass. That's kind of what an asymptote is. It's like get closer and closer and closer, but you cannot pass. Which is why we say y is greater than or above 0, but never hitting and never going below. So these are the very, very basics of an exponential function. So if I was to do something like actually fill in a number and ask you guys like either how to graph it or how to plug into it, maybe you wouldn't be quite so scared because you know what's going to happen. If I ask you for what is y equals 3 to the x when x equals something like -2, what would you guys do? If I give you y equals 3 to the x and I say x equals -2, what should you do? It's the coach saying -2, hey, get into the game. So what's going to happen?
plug it in.
Yeah, y equals 3 to the, but negative 2 has to go to his position, right? And where's his position? Okay, but we have to go back to section 6.1 to say, okay, well, what does that mean, though? Negative exponents, what does it mean? Don't you cross the line? A negative exponent says cross the line. What's going to be in my denominator? 3 to the power of, oh, careful, the negative said cross the line. I just get to put a 2. What's left in the numerator when I take them out? It's a 1. So what does that actually become? 1 over 3 squared is 9. Whoa, that's tiny. Why is that so tiny? Because if I was to graph him, and if I was to go to negative 2, do you guys remember that swoop goes down really, really low? So this would actually be 1/9. It'd be way down here. At negative 1, it would be 1/3. At 0, it would be 1. We can make a table. But the reason why this is so tiny is because exponential functions, when you have negatives, go down real low, which is where that guy is. And when you have positive exponents, they go real high. What do I want you to take away from today? Exponential functions. What's in the exponent? Back from yesterday. What's in the exponent of exponential functions? Sorry, my computer's frozen. A variable. How do the tables work in exponential functions? You add the x's and you do what to the y's?
Multiply.
Multiply. When you're looking at a graph of an exponential function, who is he? Nobody? There he is. Come on. That one's easy. We have an exponential function. What's his graph look like? There he is. And then what do you do when you plug in? Exponent. Don't worry, homework is the easy stuff. But some of you might even get the next homework this weekend. Happy weekend, guys. Happy almost Spirit Day. Try to Spirit Day in a way that you still have friends at the end. So yeah, everyone's going to be turning in their homework on.
Sound like that guy. Yeah, now when I go outside, hey.